All right, thanks everybody for joining today. Going to get started. I know we have a busy schedule here. I think people may join as we move along. I know it's summertime, so appreciate everybody being able to log in here. So hello and thanks for joining Module 2 of our Electric School Bus Familiarization webinar series. This is an ESB technical overview for school bus technicians. You can go to the next slide. All right, so just a couple housekeeping notes up front. Controls are located at the bottom of your screen, and we will be taking questions after each presentation, so please submit them via the Q&A button there. We do also have a poll for everyone on the call, which you should be able to see. There you go now. So please take a second to answer that. What job category best describes you? All right, great. Appreciate it. Looks like we have a good amount of technicians on today. This is great. We will be obviously recording these sessions for districts to incorporate in an internal training program. So happy to have you guys on. Hope everybody actively participates in the Q&A session. Next slide. So we are recording this webinar, and like I said, it will be posted. So if you speak or use video, you are presumed to consent to recording and use your voice and image. Next slide. And this is presented by the Joint Office. The Joint Office mission is to accelerate an electrified transportation system that is affordable, convenient, equitable, reliable, and safe. And our vision is a future where everybody can ride and drive electric. Next slide. And the Joint Office does support several programs that were established in the bipartisan infrastructure law, which you can see here. Obviously, that does include the Clean School Bus Program, which distributes $5 billion in support of electric school bus deployments. Next slide. So to support EPA's Clean School Bus Program, the Joint Office has partnered with EPA and the Department of Energy to provide free technical assistance to school districts that are currently receiving EPA funds or are planning to apply for future rounds of funds. The goal here is to provide school districts with the knowledge, tools, and information needed to successfully plan for and deploy clean school buses. So eligible entities can request assistance by filling out the online contact form at driveelectric.gov, or you can go to this QR code here, where that take you to that contact form. And then you're also welcome to email us at cleanschoolbusta@nrel.gov with any of your questions or issues. Next slide. So here are just some examples of how we can help, but inquiries are not limited to these topics. You can contact us on anything, simple questions to complex, in-depth assistance. We're available to discuss or review your ideas or just be a sounding board along your electrification process. Again, we provide this service free of charge, no strings attached, so feel free to reach out with anything you have. Next slide. So if you're here, you know this is our electric school bus familiarization webinar series, where we are presenting 4 modules on the fundamentals of ESB technology. The recording for module 1 was an overview for drivers, and it is up on driveelectric.gov. And that's where all modules and associated testing materials are going to be found upon completion. Next slide. And so today we have module 2 of, this is the first of 3 parts geared towards school bus technicians. As I said, we are going to have a Q&A after each presentation. And so today we're going to be starting with Angel Yin from BYD Ride on the fundamentals of ESB technology. Next, we'll have Mark Richardson from Thomas Bus Daimler Truck. with ESB preventive maintenance and diagnostics. And third, we will have Sean Ashcroft from Greenpower Motor Company, covering energy storage system overview and battery management. Next slide. And today's moderator will be John Chavone. John has been involved with transit and bus maintenance and technology for nearly 40 years. He served on the APTA staff, authored several transportation research board studies, and is now working with the Center to Advance Frontline Worker Training and Apprenticeships. John's got expertise in bus maintenance training, registered apprenticeships, zero emission bus and battery electric bus training, and integrating training in fleet procurement. I'll kick it over to you, John, and you can take it from here.
Thanks, Ryan, and thank you for attending, for taking time out of your busy schedule. I'll go to the next slide. As Ryan already mentioned, this is the first of the technical sessions, session 2, aimed specifically towards the technician, followed up by high voltage safety at the next one, and the last one will be on electric school bus charging methods and considerations. And here are all to the right, all of the OEMs that have graciously agreed to participate in this program. Next slide. The mission of the International Transportation Learning Center is to advance training on a joint labor management basis. We feel that training is much more effective if both sides work together. We did organize a similar webinar series for transit bus technicians. It went over very well. It was also a 3-part webinar series. And the purpose is to provide introductory information. You're not going to be able to work on electric school buses after this presentation, but you will have a better understanding of the key components and the concepts of the technology once you do get the OEM specific training. Next slide. I won't go through this. Ryan mentioned the 3 presenters, Angel Yin, Mark Richardson, and Sean Ashcroft. Will be our 3 presenters today. Next slide. Here's a list of key terms that we'll be using today. You'll have access to this. As Ryan said, everyone will get access to the entire presentation. I just want to make you aware of 3 of them to sort of kick off the technical presentation. All the way on the right, the energy storage system consists of 400 to 900 volt DC battery packs. This is sort of like the fuel tank of the bus. And the key term there is DC. The next term is a traction motor in the center on the bottom. It uses AC, similar to the current you have in your house, to propel or power the vehicle. It takes the place of the internal combustion engine. And because the batteries are DC and the traction motors are AC, they need to be converted, and the inverter does that. So the inverter converts DC high voltage to the AC current to power the traction motor. Okay, next slide. And with that, I'll turn it over to Angel. Again, you have any questions during the presentation, enter them in the Q&A, and we will address it after Angel's presentation. Angel?
Thank you, John. Welcome, everyone. Let's dive into it. Next slide, please. So for this section of the slide, we will define an electric school bus, identify key high voltage ESB propulsion system components, discuss principles of operation for key high voltage components, and then identify the key low voltage component for ESB, especially on telematics and V2G. And then we will compare similarities and differences with the diesel school bus. Next slide, please. Okay, so let's define a battery electric school bus first. A vehicle that is battery electric vehicle if its propulsion system is powered only by batteries. The vehicle runs on electricity only, and these batteries are charged by an external power sources. So because of these unique features of an EV, a battery electric school bus does not have any internal combustion related components. Instead, an ESB is powered by the high voltage electric propulsion system. The power batteries provide the driving force for the entire vehicle and accessories. Next slide. And before we go into details on the high voltage components, I'd like to remind everyone that safety operation is especially important for all EVs. That is because the high voltage system on the vehicle will have a voltage up to 900 volts. And this level of electricity will cause serious injury if the proper categorical 2 PPE is not worn. So be mindful of this. Safety protocols and procedures will be presented in details in the later slide by Mark and future webinars. Next slide. Okay. So a battery electric school bus replaces a combustion engine with a traction motor powered by multiple battery packs and managed through electric power control unit supplying power to drive motor and auxiliary equipment using the high voltage cables, which is the darker black line shown on the graph here. And this is called the high voltage system, or I usually think of it as like organs and veins in our body. It is commonly made up 4 key components shown here. First, we'll have the charging interface, usually located on the side of the bus. The charger plugs into charging port, injecting AC or DC current into the vehicle. And then the current goes into the electric power control unit, which controls charging and discharging to the other high voltage components and accessories. The unit includes a DC-AC inverter used to power the drive motor and accessories, and a DC-DC converter to power the batteries. So some manufacturers will put the inverter and converter into an integrated box, while other manufacturers have them as standalone components. Then DC current sent from the power control unit will go into the energy storage system where the DC powered batteries are located. After that, DC current from the battery will be converted into AC current by the control unit or the standalone inverter to power drive motors and accessories like HVAC. So this is how electrons flow within the vehicle, and we'll discuss them in more details in the next few slides. Next slide. This slide is showing a complete high voltage system on a bus layout. Just note that this is not representative of all configurations, but rather one arrangement from one manufacturer. We'll discuss each component in details in subsequent slides. Next slide. Again, we'll start with the charging interface, which include a charging port and an onboard charger. So there are 2 common charging ports, AC or DC chargers, and the port can be located on either the side of the bus or the front or rear, depending on your manufacturer. For AC chargers, sometimes you see we call it SAEJ1772, and then for DC charger can be referred as CCS1. These are just charging standard for AC and DC chargers. And then the onboard charger is used to convert AC to DC current in the case of having a level 2 AC charger. Charging the bus is a safe operation, so you don't need PPE for this. When charging, we should park the bus near the charger and turn off the high voltage system. Open the charging port hatch and the charging port caps. Make sure there's nothing strange inside and plug the charging gun into the port. Next slide. And then next, we goes into the ESS system, which include the power battery modules and the high voltage battery pack contractors. The battery system is the power source of the electric school bus. Some common composition of the battery is lithium ion or lithium ion phosphate. Generally, larger battery size enables longer range, but are also heavier. The contractor controls the current flow from the battery packs. There are usually several contractors installed in the bus acting as a switch and battery safety components. Next slide. So the graph on the right, it on the left is showing the schematic of the ESS system. The system will have multiple battery packs connected in parallel. A battery pack contains multiple cells enclosed in modules and connected in series to form the pack. Besides the battery, the ESS system will also include some battery management system and protection devices. And for the battery energy storage system, I want to bring up two key quality indicators of the system. The first of all is state of health, SOH, and state of charge, SOC, as they provide very useful data needed for the optimization of battery management system, or we can call BMS. So for optimal performance, we recommend you keep between 20% to 80% SOC and store the vehicle in temperature between 59 to 95 Fahrenheit to remain a great SOH. The performance of the high voltage power battery decreases in either super hot and super cold temperatures. If a driver notices a low SOC en route, sometimes something lowering than 20%, the driver should immediately turn off all non-critical electrical loads and unload if convenient. Use the regenerative braking rigorously while minimize acceleration, and then stop when safe and call for roadside assistance. Next slide. Next, we have the motor and accessory controller. I'd like to note again that some OEM will have the DC-AC inverter and DC-DC converter as standalone components, while other manufacturers may combine everything into one integrated unit. But nonetheless, you can think of the controller as the central nerve system, which transforms AC and DC current into the correct form and distribute it to power major bus components. Next slide. So how the AC and DC current got distributed, they actually go through the high voltage distribution system. The high voltage area on the bus are indicated in orange. These cable may be behind interior and exterior panels. There are also high voltage warnings indicated in many areas around the bus. Please follow all cautions related to these indicators when you're actually operating with a bus. In the high voltage compartment, you will also find a high voltage service plug. It is used to physically disconnect and de-energize the high voltage system, so it's an important component to remember. And I believe Mark will go through the de-energization process previously later. Next slide. Coming next is the drive motor and axle assembly. The drive motors are supplied AC power from the inverter or motor controller. Since the electrical motor is directly attached to the drive line without any gears nor transmission, there is only a drive position and a reverse position to move the bus, in addition to the neutral position when it's stationary. And then the motor is also responsible for creating the regenerative braking function during normal driving, which converts kinetic energy into electrical energy and store it in the battery when the vehicle is braking or decelerating. So in this case, the drive motor acts as a generator of electricity. There's several benefits of regenerative braking. It helps reduce the use of service brake system. It can be used for safe driving and can improve the driving range of the vehicle by recharging the battery. Next slide. And lastly, the high voltage system powers AC-driven accessories because there's no internal combustion engine and drive belt. The accessories powered by the high voltage system include the steering motor, air compressor, HVAC, front windshield defroster, and heater. And I think that's an overview of the high voltage system. Next slide. But besides the high voltage system, there's also a low voltage system operating on either a 12 volt or 24-volt separate batteries that operates the vehicle management component, including dashboards, lights, telematics, and other accessories. Again, either a standalone DC-DC step-down converter or a converter in an integrated controller will control the high voltage to low voltage and power the low voltage system. So buses normally have a front and rear power distribution box with a low voltage power disconnect switch between the batteries and power distribution box for de-energizing the buses, or we can call lockout, tagout, loadout. Next slide. The low voltage system is important because it controls the telematics, which becomes a crucial component for ESB management and vehicle to grid deployment recently. And the electronic control unit, or we can call it ECUs, are the source of vehicle telematics and collectively referred to as the vehicle's computer. So some examples of ECUs include the battery management controller, BMC, which manages and receives all battery information. And I believe Sean will talk about this later. Or the vehicle control module, VCM, which send gear selection position signals. And in order for user to see the data collected by ECUs, the vehicle needs what is called an electrical load management system, ELMS, and electric vehicle communication controller, EVCC. So ELMS provides a visualization on the screen, which allows you to see it, and then EVCC provides communication information for charger to vehicle and vehicle to grid. Next slide. So how V2G or vehicle to grid works? How does the vehicle discharge excessive energy back into the grid? It actually, inside the vehicle, DC current is being transported from the ESS system to the charger and then converted to AC current by an inverter inside the charger and sent to the grid. The power flow is controlled by signals sent from the cloud management system to the controller area network and the EVCC within the bus. So for V2G, we have both the signal flow and the power flow working simultaneously to allow the functionality. Next slide. Okay, as a recap, what are the similarities and differences between a diesel school bus and an electric school bus? The most difference is we get rid of the engine, exhaust, and fuel system. Instead, ESBs have the high voltage propulsion systems. Because of this change, the chassis, driveline, and power supply system are modified to fit this high propulsion system, and the rest of the component remain the same. So comparing to a diesel school bus, which have about 2,000 components, and ESB has less than 100 components. Thus, many maintenance requirements are significantly reduced for ESB. On top of maintenance saving, ESBs are quieter and cleaner with no tailpipe emissions. ESBs are more efficient with regenerative braking and can be used as a mobile battery source during emergency event to power the grid. There's just a lot of advantage of ESB, and I hope you all got the chance to experience an electric school bus in the future. Thank you. That's everything I have.
Thanks, Angel, for that. That was well done. And a reminder to type in any questions you have, because we'll address the questions now. The first one is the regenerative braking, is it automatic or is it operator controlled? You're muted.
Sorry, yeah, that's a great question. So the functionality, you don't need to turn it on or turn it off. It will be on the bus, but you can control it by like braking or not braking. And
so every time you apply, you remove your foot from the accelerator pedal, the regenerative will kick in, and
yeah.
same with applying the brakes. Okay, good. Is there a way that you could drive away with the charging plug plugged into the vehicle?
Sorry, what do you mean by drive away?
If you're plugged in charging the bus, is there a way the operator could move forward with the cable still connected to the bus?
Yeah, definitely.
I think it was meant to be. Is there a safety there? So say your bus is being charged, so it's plugged in, and the operator forgets to unplug it. Could you inadvertently drive away with
Well,
the
I
plug?
think if you forgot to unplug it, the charger will, once it's fully charged, the charger will sense it and just automatically stop charging.
Okay. Are any manufacturers considering going to a 48-volt system? Obviously, that's on the low voltage side. They're typically operating on 12 and 24-volt now. Any considering going over the 48-volt system, knowing that in that presentation there was what was called a DC-DC converter that takes either the 400 to 900 volts DC and brings it down almost like a voltage regulator to the voltage that's needed by any of the consumers on the bus, like the lights and so on. But is on the school bus side any move towards 48 volts?
Well, I like for us, we don't have any plan for that. I don't know about the other manufacturers on the webinar here.
Okay. Um, well, we'll get the others just to type in and to us in the chat, and I'll relay that. Because the buses are so quiet, is there an add-on sound alert for pedestrians to avoid accidents?
Well, that's a good question. I know we have several add-on options that you can alert the pedestrian or help you avoid accidents. I'm sure there will be add-ons like that.
Okay. Is there a concern with range on electric school buses? Will the typical or average school district be able to operate their buses, given the battery capacity they have on their buses?
Well, this really depends on district by district and the type of vehicles you have. So like for the larger type D, right now we have about 150 range. I think that's suitable for most of the district for one charge. But if you have a longer road, you can consider like purchasing like a smaller bus, which will have like longer range. It really depends on your needs, but I think most of the cases, electric school bus will definitely fulfill the road.
Okay. And we did get a response from Greenpower. They have no plans for a 48 volt based low voltage system. Answers that. Okay. I don't see any other questions. Again, Angel, thanks for that. Really appreciate it. Again, these slides will be made available. I know there's a lot of information being given at one time, but everyone will have access to these slides shortly after today. Okay, we'll move on. Next slide. Mark Richardson. Mark will address electric school bus preventive maintenance and diagnostics. Mark.
Thanks, John. Next slide, please. So welcome everyone to this session on electric school bus preventative maintenance and diagnostics. Our goal today is to cover the fundamentals of maintaining and troubleshooting battery electric buses with a specific focus on high voltage safety, maintenance schedules, and diagnostic approaches. We'll provide examples based on typical use cases and best practices, though specifics might vary depending on your OEM. Please feel free to ask questions at the end of the presentation. Next slide. So high voltage safety is obviously crucial when working with electric vehicles. These vehicles operate with components at dangerous voltage levels, so proper safety protocols are essential. Only qualified personnel should handle high voltage components, as unqualified handling can result in severe injuries or material damage. Always consult your OEM service manuals and training materials before working on high voltage systems, as each manufacturer may have specific instructions and requirements. Ongoing training and certification for personnel working on electric buses are also very important. Next slide. Preventative maintenance schedules for electric school buses are based on average vehicle use and conditions. Customers should tailor their maintenance intervals to their specific environmental and operational conditions. It is crucial that only trained personnel perform high voltage maintenance to ensure safety and maintain the vehicle's warranty. We will discuss typical intervals for high voltage system checks and maintenance tasks here shortly. Next slide. So as you can see here from the list, there are many traditional internal combustion engine or ICE maintenance tasks that do not apply to electric school buses. Some examples include engine belt drive inspections, clutch fluid checks, and fuel system maintenance. This reduced complexity in some areas of maintenance for electric buses can lead to lower maintenance cost over time. Next slide. So let's go over major components in electric school buses as it relates to the high voltage system. The high voltage battery, electric motor, power electronics, and high voltage distribution units. The location and nomenclature of these components can vary by OEM, so always refer to the specific bus model's documentation. Each of these components play a vital role in the overall operation of the electric bus. Looking at this image here on the slide, we can look at some of the acronyms that are laid out that once you start working on electric school buses, you'll become very familiar with and hear often. So that HVJB listed there stands for high voltage junction box. Obviously PS is power steering, pump and motor. And then LV and HV are your low voltage and high voltage battery switch cutoff. Things like charge ports, telematics charge management. And you can see, you know, the electric school bus that Thomas produces maintains a radiator, and that has to do with your various cooling systems. Next slide. Some additional acronyms to call out on this particular slide would be the BTMS. That stands for Battery Thermal Management System. Obviously, batteries are happiest when they're operating at an optimal temperature. So that battery thermal management system ensures that those batteries are maintaining whatever temperature they're happy at based on the OEM's, engineering. Let's see, any others? No, we can move on. Next slide. So now let's look at a preventative maintenance schedule. We have here, this is an example of what a PM schedule might look like. Obviously, your OEM, the school bus OEM, is going to provide you a schedule, and you want to follow that. But in this particular instance, we have an initial maintenance that is performed at 4,000 miles or 6 months. Maintenance 1 is going to occur every 4,000 miles or 6 months. Maintenance 2 will take place every 8,000 miles or 12 months. Maintenance 3 every 16,000 miles or 18 months. Maintenance 4 is scheduled for every 32,000 miles or 24 months. And then lastly, maintenance 5 is scheduled for every 48,000 miles or 36 months. These intervals are examples, so always consult your specific school bus OEM for precise schedules. And then again, you know, based on the amount of mileage that your buses are traveling, obviously, you might be doing your preventative maintenance schedule on a mileage basis. But then there's other school districts that maybe don't run that many miles on routes. So in their case, they would perform their preventative maintenance schedules on a time basis. It really just depends. If you're hitting 4,000 miles before 6 months, you're going to be running on a mileage basis. If you're not hitting 4,000 miles and 6 months rolls around, you want to go ahead and do that initial maintenance. Same goes with the rest of the maintenance schedules listed there. Next slide. So just calling out some of the things that are specific to the EV and the high voltage system for maintenance. On maintenance 1, which occurs every 4,000 miles or 6 months, like we discussed, the key tasks include a power steering motor lubrication and air compressor filter replacement. Additionally, the ancillary bay desiccant plug inspection are also crucial at this interval. These tasks help ensure the reliability and longevity of critical components. Next slide. So at maintenance 2, some of the items to call out, which happen every 8,000 miles or 12 months, would be let's see, checks that include a torque mark inspection, electric motor inspection, and transmission inspection. Coolant system maintenance and charge port inspection are also vital. Additionally, battery pack desiccant replacement ensures optimal battery performance and longevity. Really, when we're talking with customers about the preventative maintenance that's required specific to an EV bus, we will call out on an annual basis for the Thomas bus specifically. There's a desiccant filter in the battery packs that you want to change out annually. So it's a simple task, but it does require decommissioning of the high voltage system. I think Angel mentioned that I would cover decommissioning, and I'll touch on it just at a very high level. But decommissioning is the high voltage system, means safely shutting down and isolating the system to perform maintenance or repairs without risk of electrical shock or hazard. So anytime you're going to perform maintenance on your high voltage system and or your dealer, for instance, you're going to want to decommission those batteries to ensure that there's no risk of shock or other hazards. Next slide. So maintenance 3, and you'll start to notice a pattern here with some of the maintenance tasks, but maintenance 3 is every 16,000 miles or 18 months, and it's similar to maintenance 1, but you want to increase your attention due to the higher mileage, right? So maintaining consistent power steering, motor lubrication, and air compressor filter maintenance are essential. And again, this is examples of maintenance tasks related to the bus that I represent, but you should always reference your OEM's maintenance schedule because there could be other critical tasks that need to be accomplished in order to ensure that your bus, ensure longevity of your vehicle. Next slide. So at maintenance 4 schedule, every 32,000 miles or 24 months, there is a comprehensive inspection and maintenance covering major components like the electric motor, transmission, and coolant system. Your charge port and ancillary bay desiccant plug inspections ensure safe and efficient charging operations. Next slide. And then finally, at maintenance 5, at the maintenance 5 schedule, or M5, every 48,000 miles or 36 months, it builds on the previous intervals. Regular inspections and replacements prevent failures and ensure vehicle reliability. Next slide. So on the PM schedule specific to the bus I represent, there are some additional EV-specific tasks that aren't necessarily called out in the PM schedule, but are listed in that preventative maintenance booklet that's provided. So in addition to that schedule, there are some EV-specific maintenance tasks. For example, every 36 months, transmission fluid needs to be changed to maintain efficient operation. Obviously, some electric school buses have direct drives, so the transmission piece does not come into play. But if your electric school bus does have a transmission, there is likely going to be some sort of interval at which you're going to want to change that fluid out. In our case, it's every 3 years. And then every 60,000 miles, the air compressor oil separator element and main seal should be replaced. These examples highlight the need for specialized maintenance tasks unique to electric vehicles. An update we've made to our bus is if you're operating one of our current generation vehicles, that air compressor preventative maintenance task would be applicable. Buses we're producing now, we've switched over to an oilless air compressor. So, we've actually improved there in the sense that the whole oil compressor separator element and main seal replacement is no longer needed. Next slide. So this is a summary of the PM schedule tailored to electric vehicles. Again, this specifically calls out the electric vehicle pieces of that preventative maintenance schedule. Obviously, all of the other things that you're used to doing as it relates to the body of the bus, the tires, the brakes, the lights, that stuff is going to all apply and still be applicable. But this is, again, specific to the EV related task. And as you can tell, it's not a lot of preventative maintenance in relation to the EV or high voltage system. You've got a filter replacement every 3 years. You know, you've got some tasks to do, but ultimately it's a lot of inspections, etc., which is nice. So regular intervals for key maintenance tasks are crucial to maintaining vehicle performance and safety. Always adhere to the schedule to keep your electric school bus running efficiently. Next slide. So diagnostic software is essential for identifying and resolving faults in powertrain and battery systems. Confirming compliance means ensuring the vehicle meets all operational and safety standards before diagnosing faults. Typical troubleshooting involves data logging to capture and analyze system performance data, and then corrective actions are always based on the diagnostic findings to restore proper function. In this slide here, you can see when it comes to diagnosing the faults with your high voltage system, etc., you're going to have a laptop. There's going to be some sort of software program that you're going to utilize, and then you're going to connect to that vehicle with some sort of diagnostic tool that allows you to make that connection and pull CAN traces, etc., so you can provide those back to your manufacturer and really do a deep dive on what's going on with the vehicle. Next slide. Essential tools for diagnostic troubleshooting include powertrain diagnostic dongles and laptops with the necessary software, as I just previously mentioned. These tools enable technicians to interface with the vehicle's control systems and diagnose issues accurately. Next slide. Finally, here's an overview of a specific diagnostic tool used for electric school buses. This tool's capabilities include diagnosing and troubleshooting various systems within the bus. Using OEM-approved tools and software for accurate diagnostics is crucial. And I will speak to this diagnostic tool specifically, like it is, once you get in there and start playing around with it, it's very cool. The things you can see, the systems you can, turn on and turn off, and it'll just give you a greater understanding of the inner workings of that high voltage system. So again, these diagnostic tools are really neat, and I enjoy getting in there and just checking out all of the different voltage levels, et cetera, temperatures. Again, I don't do it often, so it's neat for me to get in and play around with. But that concludes my presentation. John, I'll turn it back over to you.
Yeah, thanks, Mark. Well done. Just a reminder, add your questions to the Q&A. And remember, there's no dumb question, just the one you have that you didn't get to ask. And another reminder that the next module coming up will address safety in greater detail. We'll really get into the safety and that's involved here in the personal protective equipment. One question that came through at the end of the last presentation that I didn't get a chance to ask is how quiet are these buses, and do they represent a safety concern being so quiet?
They're very quiet. So that's actually a positive thing in terms of, I know this is geared towards technicians, but some of the things we've found that benefits school bus drivers and everyone is the fact that when you're operating these things and rolling around, they're so quiet that students feel like they have to maybe speak quieter, so they're not heard by the driver. But in relation to a safety hazard, they don't necessarily present a safety hazard because they do have those noise generators on the front and rear of the bus. And once you drop below a certain speed, those will kick on and start making noise. So if there is someone who's visually impaired or whatever, they're going to hear the vehicle coming as a result of those noise generators producing that noise.
Okay, good. How much data will technicians have access to, and which data will they not have access to?
So that's a good question. It varies depending on the manufacturer, right? Like just and transparency, like working on the high voltage system. If you're dealing with a Jouley, a Thomas Built Buses Jouley, currently we've only certified our dealership technicians to work on high voltage components. So if let's say a technician at the school district runs into an issue and it is high voltage related, they would need to interface with their dealer to get that high voltage system taken care of, or problem taken care of. But same time, it is on the roadmap to extend that high voltage 3 safety training out to schools eventually, so school technicians can even work on the high voltage components. We're working towards that. And then, a lot of this software stuff, it depends on, some of it's subscription based, some of it's free. If you're working with like a free version of the diagnostic tool, it's typically like a view only type scenario. But then there are like license subscriptions available to where if you're paying for the license subscription of that diagnostic tool, it opens up a lot more options to that technician as to what they're able to do with the tool itself.
Okay, good. Is the diagnostic software included in the cost of a bus, or do they need to purchase it separately?
Yeah, it really depends on the manufacturer, but typically that diagnostic software is made available to school technicians at a school district on like I said, a view only basis. But ultimately they're able to at least plug into the bus and see what's going on with the high voltage system, if what temperatures things are operating at, what voltages they're at, and most importantly, what fault codes are being thrown by the vehicle. That's going to be super important because you'll get a list of all of the fault codes. Let's say you are experiencing issues, you'll quickly know whether it's high voltage related or not based on fault codes. And then within the fault code that's provided, there's typically an explanation of what the fault code is, and then some troubleshooting steps listed on what to do next.
Okay. How complicated is it to de-energize the bus, and is it included in the training?
So we currently don't train the school personnel on that decommissioning process. Our dealerships are trained on how to do that, but ultimately it is not a complicated process, but it is a process that you do have to give a lot of attention and care to. You need to be properly trained in order to perform it, and you need to be wearing the proper PPE when doing it. But at the end of the day, it is not a difficult process. It's just a process that you need to be very aware of what you're doing when you're performing it.
Mark, could you talk a little bit more about the certification process that the technicians will go through? I mean, you will provide that and provide an actual certification so they're allowed to work on the bus. And if you're not certified, what happens then?
Yes, I mean, as far as Thomas Built Buses is concerned, we have high voltage training, and we've got that broken out into 3 levels. There's HV1, HV2, HV3. Typically, drivers and technicians get HV1 and HV2 certified. That is available online, and that just it teaches you how to properly and safely operate the bus, and it also teaches you just about the high voltage system and the dangers that there could be and how to safely work around it. But then HV3 training is an actual in-seat training. I want to say it's 2 to 3 days long, and each and every participant actively decommissions and recommissions a vehicle, and you just take a much deeper dive on how to appropriately work on those high voltage systems. So in order to touch anything high voltage related, as far as maintenance is concerned, you have to have that HV3 certification. Currently, our dealership technicians are HV3 certified. And then, like I said, on the roadmap, there is a plan where essentially we've trained, all of our dealerships have trainers that train, school districts. And there is a plan to roll that out to school districts eventually. I would need to circle back to our training folks to find out what that timing looks like.
Okay. What is the most common issue that would require troubleshooting, and how does it compare with an internal combustion engine bus? But I think Ryan says he'd like to answer that question live. So Ryan?
Oh, no, I was just indicating that it would be answered live.
Oh, okay.
Sorry,
Sorry about that. Mark, yeah. So what is the most common issue that would require troubleshooting, and how does that compare to internal combustion engine bus?
That's a good question. I mean, we've seen various issues. If it relates to the high voltage system, essentially, we get our dealerships get involved, and then they work hand in hand with our partners. Our buses are powered by Proterra, so between the dealers and Proterra, and then Thomas, obviously, there is a teamwork effort on diagnosing and repairing whatever issue there is related to the high voltage systems. Sometimes it is as simple as loose connectors. So if we're talking about what's sort of typical, I've seen plenty of, not plenty, I don't want to say plenty, because we've got a lot of several school bus deployments. We've got more than 1,000 out there rolling around and operating on a daily basis. But when it comes to issues that we've seen, some of the stuff is as simple as a loose connector, right? Somewhere within the high voltage system, or a loose ground. Once you're able to identify where that's at and get it tightened up and rectify it, the bus operates as advertised, and you don't have any issues moving forward. Some other issues that the school bus technician might not deal with directly, but it's good to know who to interface with and sort of who to bug to get it fixed, is you might run into, and this will be covered in a later module, but charging issues, right? So that might be something that school bus technicians deal with. Hey, bus X is not charging on this particular charger. And at that point, there are some simple troubleshooting steps they can do to figure out if it's a bus problem or if it's a charger problem. And then from there, it's just knowing who to interface with, right? You need to reach out to your EVSE provider, let them know that the charger's not working, and do some additional deep dives with several partners included. So there's a lot of collaboration that happens when it comes to repairing electric school buses.
Yeah, and the tip is always think of the simple things first, right?
Right. Yeah, for sure. As simple as the low voltage switch was cut off. That's why it wasn't charging, right? So.
Yeah. Okay. Well, will there be a need for multiple interface cables to connect PCs to? I think your photo showed quite a variety of cables there.
Yeah, that was just depending on the connector that your bus utilizes to basically relay the CAN data, et cetera. There are multiple attachments, or dongles as they call them, to ensure that the tool you're using to actually, feed that diagnostic information to your software program on your laptop is compatible with the vehicle. So depending on the diagnostic port that the vehicle has available will depend on the accessory or dongle that you'll need to connect to the vehicle.
Okay. Do OEMs use specific fault code numbers or any other identifiers, or do all OEMs have the same fault number for the same fault condition?
That's a good question. I am not positive on the answer to that, but I will say I would imagine that it's those fault codes. I don't think they're necessarily universal. Maybe there are some that are universal, but there would definitely be faults that would be specific to the particular battery system and high voltage system, traction motors, et cetera, that each school bus provider is using. So I would think that the fault codes would be unique to the vehicle, but I could let Greenpower or BYD weigh in on that at a later time.
Yeah, we'll seek the answer to that and then list it in the appropriate place in the slides afterwards.
Okay.
Okay, here in the world of personal EVs, I guess that would be like cars. OTA updates are common. Will electric school buses also benefit from regular OTA updates? I assume, I'm not sure what OTA means.
Yeah, it's over the air updates. So it's essentially, you come in the next day and your bus had an update and you didn't realize it. Those can be a positive thing, and they can be a negative thing in terms of, I've seen, and this isn't vehicle related, but actually, yeah, if we're talking passenger vehicles and even chargers, I've seen over the air updates essentially take down your vehicles and or your chargers. And then obviously the folks that push that update out are scrambling to fix it. We kind of saw that recently with the CrowdStrike over-the-air update that took down a lot of systems for airlines, et cetera. But currently, we have over-the-air update capabilities, but we're not utilizing that currently. I do think in the future, we definitely will utilize that as an easier means to get updates completed. But right now, whenever we're doing stuff like that, it's typically in a campaign fashion that our dealerships handle for us. And again, it's just to control that scenario where an over-the-air update is pushed and inadvertently breaks something that wasn't expected.
Okay. How does preventive maintenance play a role in mitigating water intrusion into the HV system? Is there a specific PM task?
Yeah,
that
very.
deals
So
with-
that was, and I should have better explained it, but so that's the one major preventative maintenance task that we call out that's specific to our school bus is annually you're going to want to replace a desiccant filter, and it's a filter that runs the length of the battery pack, and it's essentially the same thing as those packs in shoe boxes that keep moisture from building up. It's going to absorb any and all moisture that gets into that battery pack and keep it dry. So ultimately, in order to replace that filter, it does require you decommission the battery system. Simple process. You just want to take special care when doing it. But again, that is one preventative maintenance task that specifically keeps moisture out of the battery packs in the high voltage system.
Okay. Do PMs on electric school buses take more or less time than, say, a diesel or gasoline bus?
It would be less time because as it relates to the preventative maintenance task from an EV perspective, annually it's that desiccant filter, and then on a scheduled basis, it's a lot of inspections, power steering pump lubrication, and then everything that you would typically do on a school bus on the low voltage side and the body side. If you think about what you would need to do from a preventative maintenance perspective to a diesel school bus or an ICE school bus, you saw the list. It was a long list of things that are no longer applicable for EVs. And so it's definitely it's an easier preventative maintenance schedule than what you deal with on the ICE side.
Okay, one more question. What's the typical life of a battery pack, and are they serviceable?
So yeah, battery packs are serviceable, and we offer standard, and most school bus manufacturers are like this. I think BYD has a different standard warranty, which is longer, but our standard warranty is 8 years and or 175,000 miles. And then, there's also extended warranties typically available for battery packs. And from our perspective, we fully expect that our battery packs will last the life of a school bus. So if you're operating that school bus 12 or 15 years, the expectation is that pack lasts the life of the school bus. You can even look at some of that warranty language. I won't go into the specifics of it, but ultimately, if you get that, let's say you get a 12-year extended warranty, right? There's going to be a guarantee within that warranty that states you'll have, say 70% usable capacity left at the end of 12 years. And if you've still got 70% of usable capacity available on that battery, depending on the size of those battery packs, you can still cover all the routes you were originally trying to cover and have plenty of energy left in those batteries when you go to retire that bus to find some sort of second life use case for the battery packs.
Okay, very good. Well done, Mark. Really appreciate that.
All right, sir. Thank you.
Thanks for that good presentation. Next speaker is Sean Ashcroft, and he will address electric school bus energy storage system overview and battery management. Sean.
Hi, everybody. Next slide. So my learning outcomes are going to be defining electric school bus energy storage system, defining cells, modules, and packs. I'm going to describe why a BMS system is needed, and also describe why a battery thermal management system is needed. Next slide. So the term energy storage system, it's used in various forms, but it generally means the complete battery pack system. The ESS is a combination of cells that are mechanically and electrically connected, along with appropriate thermal, electronics, and mechanical structure to house the entire unit. Depending on the OEM, the number of packs used for the energy storage system will vary. Here on the left is an image of a single high voltage pack, which is used on an electric school bus, and it is equivalent to a diesel fuel tank on an ICE school bus. Next slide. So some design factors that dictate the capacity, which is measured in kilowatt hour of the energy storage system, are range, voltage, performance, and weight constraints. A commonly used battery cell chemistry is the lithium iron phosphate, or abbreviated as LFP. A single cell has a nominal voltage of around 3.2 volts per cell. Here in the middle of the slide is a single prismatic LFP cell. It's enclosed in an aluminum enclosure, and then right below the single cell is a module. Inside this module, for example, in this case, there's 8 cells that are connected in a series arrangement, and these modules get connected in a series or parallel arrangement, and this builds up which is known as a pack. And again, depending on the OEM, there may be multiple number of packs connected in series to make the energy storage system. Next slide, please. So here is a basic overview of an electric school bus energy storage system. We have 3 packs wired in series here, and you can see the alternating poles in between the packs. Some common high voltage components of the energy storage system are shown, which has been shown on previous slides as well. In the middle, you have the high voltage junction box, and just north of that is the onboard charger, which converts the grid split phase AC to high voltage DC. And then we have our inverter and our traction motor, and as well as the DC-DC converter, which is converts the high voltage DC to low voltage 12 or 24. Again, some of these components can be integrated into a single into a single device. It just depends on the OEM's design. Next slide. So the battery management system, what is it and why is it needed? So the BMS is the brains to the safe operation of the energy storage system, and it does that by performing critical roles such as measuring cell voltage and temperature. Each individual cell voltage needs to be measured to avoid dangerous situations that can arise from a cell being either too low or too high. Here's a picture of a prismatic LFP cell that was overcharged, and it was permanently damaged. You can see that the cell is swollen in nature. The BMS prevents that from happening. So the BMS also facilitates cell balancing within the packs, and by balancing I mean it helps reduce like a high charge on a single cell or multiple cells to help equal out the charge in the individual cells. The BMS, it also takes temperature readings from within the pack and also on the cells. I will go into details about why temperature is important in a later slide. Also, the cell voltage and temperature are the 2 main data points that the BMS takes into account to dictate allowable charging and discharging limits of the energy storage system. Also, the BMS, it measures the energy storage system current, and this is useful for calculations such as range estimation, SOC, which is state of charge, and also battery health. The battery management system, it when it differs, the battery management system, it also measures the isolation resistance. The isolation resistance is measured for an added degree of safety. Both in electric school bus, both high voltage minus and high voltage positive poles are isolated from the vehicle chassis. So for example, the high voltage minus is not bonded to the vehicle chassis like the vehicle's low voltage system is in the internal combustion engine design. And the BMS is tasked with control of ancillary high voltage loads because there's times when certain components might need to be shut down to reserve power for key components such as inverter and drive motors. And lastly, another safety system that was previously discussed by Angel is the high voltage interlock loop. So the BMS monitors this. It's a set of secondary contacts that are embedded into a high voltage connector housing. And when two mating high voltage connectors are disconnected, the high voltage interlock system loop is broken. And how this plays out is if the vehicle is energized and someone were to accidentally disconnect the high voltage connector, the BMS would monitor this break in the HVIL loop and it would immediately de-energize the bus to prevent any kind of accidental personnel contact with the high voltage. Next slide. So this is an image showing a distributed BMS topology using the CAN physical layer. So the CAN physical layer is how it's showing how the devices are all wired to each other. It's a communication protocol. So again, we have some common high voltage components of the electric school bus here. And the black lines in between the various components represents the CAN communication wires. So inside of each of the 3 battery packs in this example lives the BMS slave modules. And the module's role is to record the physical data measurements of cell voltages, temperatures, and also perform the cell balancing. So each of the slave modules CAN communication wires are daisy chained along from pack to pack, and then ultimately back to the BMS master module, which is located in the middle of the slide. So the master module processes all the data from the slave modules, and it's programmed with logic to make decisions such as setting charging and discharging limits. The BMS is critically important to having a safe and reliable electric school bus. Next slide. So right now I'm going to be going into why a battery thermal management system is needed. So when the electric school bus is required to charge or discharge, a chemical process takes place within the battery cells, which allows electrons to move. This chemical process can be negatively affected by extreme ambient temperatures. For example, with the lithium iron phosphate chemistry, you cannot charge the bus when the temperatures are less than 0 degrees centigrade or hotter than 55 degrees C. This BMS system is incorporated into the energy storage system by the OEM to mitigate these extreme temperatures within the battery packs. Some common BTMS components include refrigerant, compressors, pumps, heat exchangers, valves, fans, and again, this BTMS system is all automatically controlled by the BMS. It doesn't involve any kind of operator interaction. Next slide. So here displayed is a generic example of a BTMS system. It's using refrigerant for the cooling function, and there's an electric water heater for the warming of the coolant, which ultimately travels into heat exchangers mounted inside of the packs. And lastly, next slide, please. This is just a little a basic graph of how temperature can negatively affect the LFP discharge performance. So if you were without a battery thermal management system, you could see the blue line here. The blue line here represents a LFP cell that is discharged at negative 20 degrees centigrade, and the capacity is reduced to about a third. So you can see it's right around the 70 amp hour line on the x-axis, where if you had a battery thermal management system, you could extract the full rated capacity from the pack. So you can see the red and the black lines, they're right around the 110 amp hour. So you really having a BTMS system is extremely important in these electric school buses. And that concludes the end of my slides. I'll open it up for questions and answers.
Yeah, thanks, Sean. Good job. If my handy calculator is correct, that means the BMS has to monitor and control over 150 cells on the bus. Is that right?
Correct.
Okay. Yep. Pretty extensive. Do the high voltage and low voltage batteries share the same grounding system?
So the enclosure, the battery pack, the high voltage battery pack enclosures, the enclosures are typically connected to the school bus's chassis, but that's it. The high voltage minus and positive poles are not connected to the chassis at all. That's that isolation that I was talking about. We want to galvanically isolate the high voltage from the low voltage.
Yeah, thanks for that. That's important to note that the high voltage grounding is kept separate from the chassis. Yep, good. Is it okay to charge a bus while on the lube rack when you are working on it? This particular person asking the question has seen this done before.
So the lube rack, is that just it being
Yeah, I guess
suspended?
let's say while it's being serviced or being worked on.
Depending on the degree of what components are being serviced, I wouldn't see a problem with it.
Okay. Let's see. Why do the batteries need to be heated?
So the batteries need to be heated because with the lithium iron phosphate batteries, anything below 0 degrees, you can damage them if you were to try to charging them if they're below 32 degrees Fahrenheit. So we heat them so that we don't damage them while charging. If you're operating them in that cold that cold environment.
Okay. I'll just give people a minute or so. That's the last question I have. We are running, we're ahead of time here. So if anyone has a question, don't hesitate to ask it. I'll just wait a few moments here for another question to come in. Okay, well, hopefully that was informative for you listening in. I know there's a lot to take in, but as we say, the slides and the recordings will be available to you afterwards. Next
John,
slide.
we did get one more.
Oh, we did?
One more question.
Oh, okay. Yeah,
Maybe
I
you
see.
just can't
Yeah,
see it.
I see it here. Are the temperature ranges you mentioned affect DC charging and AC charging, or just one style of charging?
So yes, depending on the DC charging, depending on how high the DC charging rate is, it could be hindered by the temperature of the battery. So AC charging, the charging rate is generally very low compared to DC charging. So AC charging isn't like, for example, if the battery, I'm just gonna throw some numbers out there. If the battery is between 40 to 50 degrees Fahrenheit, you may be limited to around 75 kilowatt hour, 75 kilowatt. And if you go above 50 degrees Fahrenheit to, for example, 80 degrees, you could charge at the full rated level. And so with an AC charging, the max you're going to get is around 19 kilowatt into the energy storage system. So that colder region won't affect the level 2 charging.
Okay, and one more question. Will the bus tell us the temperature? Will the bus tell us the temperature of the bus? I think mean temperature. Yeah, will the bus let the driver know or the techs know what temperature of the bus is or what temperature is out there?
The ambient temperature, or
Yeah, I just repeat it. Will the bus
batteries, right?
will the bus tell us the temperature of the bus?
In terms of charging, probably. Like you're saying, you need to have a certain level, certain degree to be able to charge. So I'm wondering if if there's something that indicates
Yeah, it must be
if it's warm enough to charge.
So speaking for Greenpower, our vehicles have a multifunction display, and through that multifunction display, you can view like parameters such as the hottest and the coldest cell temperature, and it will give you an indication that you can see that information.
And we'll also give you the ambient temperature as well.
Yes, we have it. Yeah, yes, it will.
Okay, now I see no additional questions. So again, thank you, Sean, for that. We'll go to the next slide. And remind you that Module 3 is coming up. Will be on high voltage safety considerations. You'll get ample notice when that is scheduled. And the final module will be on charging considerations. And I'll turn it over to Ryan.
Great. Thanks, John. And thanks to your whole team at ITLC. Thanks to the team here at Joint Office, and especially thanks to Angel, Mark, and Sean. Those are all really great presentations. Really appreciate it. I think the technicians who are on here, I'm sure appreciate it. And everybody that's going to watch in the future, it's going to be a great resource. So definitely want to remind everybody, if you're not subscribed to the driveelectric.gov newsletter, you can do that and you will be notified when registration for Module 3 opens up. If not, you can always go back and check on driveelectric.gov/webinars. That's where you will see the registration once it opens up. We hope to have that webinar going here in a couple months. So like we said earlier, these next two modules, they will be geared towards technicians again. Again, if you're looking for technical assistance, please don't hesitate to contact us, cleanschoolbus.ta@nrel.gov, or you can go to the contact form listed here. Appreciate everybody joining. I know it is still summer for most of you, so thanks for taking the time out of your summer vacations if you're on them, and good luck when the school year starts. And we look forward to seeing everybody here in a couple months for Module 3.
Hey, Ryan, just one last question. I think there was at least one question that wasn't answered. We're going to go and answer that question. How will that be presented to the audience? That unanswered question.
The unanswered.
Yeah, we're going to look up. There was one question that we need to do some research on. Will
Okay.
it show up in the presentation somewhere?
Yeah, so we'll probably include the question and answer when we publish the slides. I would say if we have any follow-ups, we can include them as an additional slide once we publish.
Yeah, there was a question about the fault codes across OEMs,
Yeah.
if they were similar or dissimilar.
Yeah, yeah, maybe we can gather the answers and add them as an additional slide. Maybe if there's anything else. Yes, for the battery charging. Yep. So
Good.
that was for the last question, the battery charging temperature. All right.
Great.
I appreciate everybody joining. Thanks, John and everybody. We'll see you guys next time.